Dana Goward, the president of the Resilient Navigation and Timing Foundation. It's a privilege to have you on Geospatial FM.
Well, it's a pleasure to be here. Thank you very much.
I'd like you to help us understand how GPS affects every corner of daily life. I hear you've got a nice graphic on your website.
So yes, GPS is a silent utility, and I will share my screen. And one of the ways that we show that is on our website. For the Resilient Navigation and Timing Foundation. By the way, we are a 501c3 charity, and in the United States, a charity is an organization that can have members, but is prohibited from advocating for and directly benefiting its members. Its members support the mission. So we are a public benefit charity advocating for policies and systems to protect GPS satellites, signals, and users. And we focus on the users because, quite frankly, well, everybody loves GPS and it's a great system. Most people don't care about the satellites. They don't care about the technology of the signals. What they care about is that they get the positioning, navigation, and timing services that they need when and where they need them. And as I said before, it's almost always from GPS or a combination of GPS and other satellite systems. So
I love this term that you're using, a silent utility. And yes. I also loved this comment you made. It's a bit provocative, actually, I think, because it goes against most people's understanding of GNSS and the particular GNSS known as GPS, that it's used for timing, perhaps more than location. I don't think most people think of it that way.
Yes, so that's true. So of positioning, navigation, timing is the one ring that rules them all, if you will. So GPS satellites are essentially 3 rubidium clocks with a transmitter connected to it, and they basically are just transmitting time all the time at the same absolute instant, highly precise and synchronized time. And the way that your device determines where it is in three-dimensional space is it senses when those signals arrive at your device. It's a miracle of math and microprocessing, and it figures out exactly where you were. But it starts out as a timing signal, and timing is incredibly important to synchronize all kinds of operations in information technology, to make sure computers are running at the same time and they're synchronizing and properly ordering their transactions. Cellular telephones, for example, have to be able to synchronize both with the tower, and the towers have to probably most importantly, synchronize with each other so that they can communicate back and forth. So this is our GPS is everywhere, a little applet. And if what you can do is you can mouse over everything and something will pop up and tell you how GPS is involved. So for instance, right now we're looking at a plate of food, and this will bring you to information about precision agriculture, which is enabled by GPS plus an add-on technology called RTK to give you hyper precision, and it allows farmers to put a little bit of fertilizer and a little bit of pesticide right next to the seed, and then come back later and then harvest the plant that grows from that seed all automatically, right? And it reduces the cost of the farmer, it reduces the cost of the environment because of less runoff, and it makes farms much more productive. And that's just one narrow example of how GPS, global navigation satellite systems generally, but how the GPS was the innovative technology probably of the last 80 years, and the one that's been of most benefit to the world. Again, you can mouse over and see how it applies to aircraft and aviation, down here to automobiles. For your GIS folks, certainly surveying is a big deal. Financial system, absolutely. So how does your bank know that the money's really there, right? And when you do credit card transactions and that sort of thing, certainly the internet and devices need to be able to connect wirelessly and synchronize with each other and with databases. And so ATMs and checking and credit card transactions all rely on the connectivity and the forensics in terms of date stamping, time and date stamping that are provided by GPS timing and time, right? So there's a difference there for your GIS folks.
There's an incredible number of quite provocative remarks you're making here, Dana. So you said it's GPS or GNSS, we could say, is one of the most significant technological advancements of the past 80 years. Simultaneously, as I sort of flagged before, you've said it's this silent utility. There's a lack of awareness really amongst the public. You know, everyone thinks of it in terms of location, but you've basically said that it's at the center of really trillions of dollars of money flows almost every second around the world in terms of point of sale systems and synchronizing transactions. There's an incredible amount of importance vested in this network of satellites.
Absolutely. And that's why other nations have built their own GPS-like systems, right? But you know, there's a challenge with that because all of these GNSS systems share similar frequency bands and they cooperate, which is a good thing. But at the same time, the fact that they're all in the same frequency band and the fact that GPS and other GNSS signal specifications are public so that people can easily adopt them and use them is a double-edged sword, right? Because they're very, very weak signals. One or more of the systems can be interfered with by jamming very easily low-powered receiver. And because the signal specifications are public, they can be imitated very easily. So you really have a denial problem and you have a hacking problem too in terms of corrupted information being transmitted.
I've also heard the terms jamming and spoofing, so that takes us nicely to the next agenda item. What is the significance of the map on your website called Where GPS Was Jammed Yesterday?
Yes, so this is a site called gpsjam.org, and it uses transmissions from aircraft, commercial aircraft, their ADS-B system, which uses GPS to help avoid other aircraft and to inform air traffic control and facilitate air traffic management. So you can see all of the green areas where commercial air traffic transits on a regular basis. Now, in this particular instance, you can see some conflict areas and some not so conflict areas, but areas that are still contested and where interfering with GPS is part of the daily life. And the red and the yellow reflect low navigation integrity messages from those aircraft advising air traffic control and each other that they don't have as much confidence in their position as they should ordinarily. And so this gives you a kind of a quick and easy overview of where jamming and spoofing has been going on. It's refreshed every day, so that's why we say this is where
That's
it was
really amazing.
yesterday. Yeah.
Does it go to other parts of the world as well? Because in your initial comments, you're basically saying in a way it's a bit of a proxy for conflict zones or war zones, but you said that also jamming can occur outside of war zones.
Absolutely. So you see in Kashmir there, where India and Pakistan get cranky with each other. You can see there in Myanmar. In the lower right, and let's take a look over at the United States and see what's going on there. So we have some interference there, or I should say we have low navigation integrity reports there. Some of these, especially the ones in South Texas, and well, the ones you see there in Nebraska and Oklahoma as well, some of those are reports from military training aircraft that are doing aerobatics. And so because they turn upside down and move away from the GPS signal, they will broadcast the fact that their GPS and navigation integrity isn't that great.
It's a false negative.
Yeah, that's right. But
still fascinating.
Yes, right. Absolutely. But looks like there's something going on over in the Mobile area, as you can see. And this sort of thing happens periodically on an accidental and sometimes on a malicious bases in the United States. Let's see what else we can see here. Nothing going on. Really, the hot zones, though, are, as you would imagine, over in Ukraine, down in the Middle East, over in the Persian Gulf with the Iranians and the Straits of Hormuz.
This is an amazing map.
Yeah.
It's almost an easy way to sort of get an update on where things are happening in the world that you might want to dig into further for detail.
It is, and it's, position, navigation, timing, generally, and certainly GPS disruption is a form of electronic warfare. It's also a form of great power competition. So this area in the Baltic has been around since Christmas of 2023, I think, and it's sufficiently far from the Russian homeland that there's really no reason in terms of military and security reasons for Russia to be doing this kind of interference to protect themselves from drones. But what happened was back in December, Christmas of 23, was the Poles activated a U.S. Aegis anti-missile system on their border with Kaliningrad. And ever since then, Russia has been expressing its displeasure with Poland and Finland and Sweden for growing closer and closer to the West by interfering with GPS signals and making life a little bit more difficult.
How do you achieve this kind of jamming and spoofing?
So we do know that Russian vessels have been the source of GPS jamming and spoofing. And I will point out that GPS signals are line of sight because of the frequency and such. And so interference with them is a line of sight as well. So it shows up much more frequently in aviation than it does other places because the interferer is on the ground and the can be seen by a lot of aircraft, right? Although the interference in maritime is pronounced in some areas as well, especially the Persian Gulf, where we've seen groundings and collisions of ships result from
I remember last week. Yep.
So
there were a couple of Chinese tankers, right, that were going off course around the Strait of Hormuz. Yeah.
The challenge is that the GPS and all GNSS signals are so very, very, very faint. It doesn't take much to interfere with them. And if you have a reasonably powerful transmitter, you can interfere with them at a very great distance. We have on our site at some point a blog post of the Russian interference array in Kaliningrad. Somebody took a picture as they were crossing the border. There's open source information on all kinds of Russian electronic warfare devices. So, you can interfere with GPS signals from little pocket devices that you can put in the power outlet of your car to giant fixed arrays that cover half an acre or so. It all depends upon who you are and how much money and time you want to invest to interfere with them. And then, of course, there's and so jamming's bad, but jamming at least is denial, and we know when you don't have a signal. Although, quite frankly, sometimes when a ship or an aircraft is approaching an area of jamming, the GPS device will not stop working immediately. Rather, it will try to find where it is, and it will sort of follow the false jamming signal for a while. And so that can tend to lead folks astray. And that, of course, is much more dangerous than not having any signal at all. Much more.
Sorry, I also had because it's tempting to zero in on the positioning and navigation elements of this PNT acronym.
Yep.
But I suppose also for all the hapless folks trying to execute credit card transactions in the red spots here, are they also not going to be able to go through those transactions?
Well, again, a lot of the jamming comes from terrestrial sources right now, and so there are a lot of things that are shielded by buildings and other things from these terrestrial sources. It is possible to disrupt from the air or from space. We're beginning to see a little bit of a disruption from space, but not a lot. But yes, we have heard Finland and Sweden reported telecommunications outages because of undoubtedly of Russian ships transiting along their coastline or through the Baltic anyway, jamming and spoofing. So while we see it most in aviation and probably next in maritime, it's certainly possible to interfere with any system that requires GPS signals and timing. Now, in fairness, a lot of the internet systems have multiple sources of GPS-derived time coming from different directions, right? So they tend to be a little bit more robust, but it's a concern because there are any number of things that could interfere with the system overall. The sun could be particularly active and deny all GNSS signals to the Earth, and there could be you could have targeted attacks by criminals or terrorists. We had in the United States, we have a celebrity chef called Guy Fieri. This is a little minor example. He had $1 million of his own tequila was stolen by thieves using a GPS disruption device. So
even the tequila isn't safe.
No, it's not. No, it's not. Yeah.
Okay.
Yeah.
I was about to ask you for some examples, Dana, but I'll take that one. That's perfect.
There you go.
Okay. So on the topic of maps, there's another one you've got there where GPS is being jammed right now. So just for the interest.
Sure, and I'm hoping that you're able to follow it. And so this is actually a spoofing map. Oh, here we go, and there we are. And this is the site. It's called GPS Wise right now, and it's a near real-time spoofing. So what this is showing you is where bad location information is being reported by different airplanes. And you see there's a big circle there. It says 159. So if you zoom in on that, you'll find 159 different airplanes that are being deceived. And you can also mouse over the particular airplane, get a bunch of information about it. And you can even get a picture. Oh, okay, that one's not found, but you get the idea. It's all connected.
So just to be specific, to be precise, so jamming sort of knocks out anybody's ability to receive the service of positioning, navigation, and timing. And it seems like it affects any GNSS. So, for example, even those Chinese oil tankers trying to navigate the Strait of Hormuz last week, presumably they were trying to use Beidou. So it seems like any of these, as you keep saying, weak signals will fail to provide a positioning outcome. But spoofing is something different.
Yes. So to be clear, most maritime devices that I know, that certainly the automatic identification systems use GPS, and they have yet to have any other of the GNSS approved for incorporation into those devices. So, but it's true that all GNSS use the same general frequency band, and it's actually harder to interfere with just GPS and not impact Beidou and GLONASS and Galileo, because you have to have a much more precise transmitter, because any leakage across the spectrum is going to get all the others. And, none of these devices are UL approved. So, they make them relatively inexpensively in most instances. And so they all deny GNSS, all the GNSS at the same time for the most part. Now, spoofing is a different issue. Again, GPS is the only signal that's approved for maritime and aviation use, and GPS is what is being spoofed in these instances here. It is possible to spoof the other GNSS because their signal specifications are well published and known as well, and we have seen papers and demonstrations of people building devices that can spoof all of the 4 GNSSs all at the same time in the same direction. It's not that difficult. It's just a matter of, software and some pretty inexpensive parts, electronic parts.
Right. So to spoof a plane, for example, it give the pilot the false impression that they're going in the opposite direction than they are going, or there are quite malicious outcomes here. For example, you could direct a plane into a mountain.
Yep, so that's certainly the case. In 2019, we had a aircraft that was approaching Sun Valley, Idaho, was a case of inadvertent interference, we believe, but they were following the signal. It was a weak jamming type signal, but they were following a signal, and they almost impacted a mountain as they were flying through the haze. For the most part, aviation folks understand the possibilities, especially when they're flying through these regions, and they do have other ways of navigating, and they know to ignore the bad GPS signals in these instances. We have had reports of folks almost violating international airspace over Iran in one instance near a missile site. We do know that at least 38 people have died because of GPS interference and spoofing.
Really?
Yeah. So
where was that?
It was Christmas of this last year, actually, in Azerbaijan. Actually, it was an Azerbaijani airplane.
Yes.
Right.
Okay. So yeah, I remembered that because this is actually the second time the podcast has gone into the PNT vertical. The first one was Eldar Rubinov. He talked about SouthPan and other satellite-based augmentation systems, and he published a lengthy sort of analysis because he's from Azerbaijan when that happened. Okay, all right. So
I know Eldar,
yeah. There you go. Perfect. Okay, so now I feel like I'm accomplishing something, connecting up significant folk around the world in this space. Okay, so you've well and truly sold how important the Resilient Navigation and Timing Foundation is, Dana. You've got a very important problem to solve. Trillions of dollars of transactions, millions of people in the air at any one time. We don't want them flying into international airspace nearby missile silos or into mountains. So what is your foundation doing to address GPS jamming and spoofing?
So, as I said, we advocate for policies and systems to address that, and we have basically three categories of recommendations. First was to protect the frequencies, right? Do everything you can to keep people from interfering with it, and that seems to make sense. But quite frankly, in most nations, don't have a monitoring capability and don't have a whole lot of capability to, once they find interference, to respond to it and to eliminate it. And I will say that the European Union has done some studies, and they find that 90% of interference is accidental, spurious radio frequency transmissions from malfunctioning equipment and other kinds of things. That said, they found 450,000 instances in their sampling, and 10% of that, so 45,000, were intentional. So that's not a small number either. So protect the frequencies. Toughen the receivers is the second bit, and toughen the users. So most folks are using relatively simple devices that can't distinguish a fault signal from a good one, and they can't distinguish when the signal is coming from next door as opposed from space. So we encourage folks to use, depending upon their application, more expensive, more sophisticated receivers, so they're less likely to be spoofed or jammed. And then we talk about augment, right? So GPS and other GNSS are great. Everybody should use them whenever they can, but they can't be the single point of failure for our whole world, right? They're very low power, very easy to interfere with naturally or through malicious intent. So we believe that every nation should have its own sovereign PNT capability in terms of cooperating with signals from space that are provided by the GNSS operators, but at the same time having the ability to guarantee other sources of positioning, navigation, and timing in the event that great powers start to argue with each other. There's we have the Kessler effect, which is, massive collisions of satellite in space that destroy a bunch of satellites. There's a Carrington event, which is the sun and, severe solar weather, or some other reason. Or they just don't want to be subject to the great powers saying, we're going to turn it off because, we you're not doing what we want you to do. So we think everybody should have, including the owners and operators of GNSS, should have a terrestrial capability as well. China or Russia do have those capabilities. South Korea, Saudi Arabia. The UK is building a terrestrial ELORAN system. Folks are investigating fiber timing systems, and we argue that there's a core national PNT architecture that everybody should have, and it should consist of terrestrial broadcast, fiber, and signals from space. 3 different sources of PNT that in total are very difficult to disrupt because their source and their phenomenology is so different from each other. So
that does sound like the definition of resilient data.
Yeah, we think so. And systems engineering tells you if something's really important, you should have at least 3 or 5 ways to get it.
So I wanted to say here, it's absolutely fascinating, and I've spent a bit of time digging into this myself in preparation for other episodes. I'm aware of actually a company that's been on a tear, honestly, in the stock market recently, NextNav. And my reading around this industry and flowering of alternative or resilient PNT technologies is that the US government in the past decade has been trying to stimulate the emergence of this resilient approach to positioning and navigation and timing that you've been talking about. And they've been funding new technologies, for example, what NextNav is selling. Do you have any commentary here?
So we have filed comments with the FCC several times about NextNav particularly, and about position navigation and timing writ large. I will say that we believe that, so what NextNav has actually asked the Federal Communications Commission to do is to accept their unsolicited proposal and award a sole source contract, because in exchange for doing what they say they will do, they want $5 billion worth of spectrum. So we think that similar or better systems can be had for a lot less than $5 billion worth of spectrum, and that there are, and despite what NextNav says, there are other terrestrial systems that meet or exceed what they say they can do. So we've counseled the FCC to proceed very cautiously and to examine NextNav's claims very, very closely, because we also believe there are other people. If the FCC decides that's what needs to be done, there are also other companies that can do the kind of system that NextNav says that it can do. So, yes.
I love this comment. What can I say? You are protecting actually taxpayers from unnecessary spending here. A question I had with the likes of NextNav is that it seems like there's a huge investment, almost like a grid of transmitters that will need to be installed across the country. Is that true?
Well, so let me just point to what the Chinese and the United have done and what the United Kingdom has done, just as an example. So the United Kingdom is planning for 4 transmitters to cover all of the British Isles and all of their contiguous waters out to 300-400 nautical miles, right? But that's going to be done with 4 transmitters, and they will be able to have timing down to the probably 50 nanosecond level or better, which is pretty good. Most telecommunications requires a microsecond, so we're 1,000 nanoseconds right now. So that certainly future-proofs them and provides them with a really good background. So it all depends on. There's also a system in the United States being offered to the FCC in parallel at the same time as the NextNav proposal, called the Broadcast Positioning System, and that's using next generation television to deliver timing and eventually location information. In fact, there are many that say a combination of ELORAN and the Broadcast Positioning System, kind of the ideal combination because of the location differential of the transmitters and the spectrum frequency separation between the signals and so forth. So yeah,
is this almost leveraging an existing set of TV broadcast antennas?
That's the idea.
Okay.
That's the idea.
Gotcha.
And quite frankly, if someone didn't want to put up any additional infrastructure for ELRAN, they could use AM radio towers, or actually the guy wires of AM radio towers to broadcast that signal. So the number of in our mind, the number of transmitters required is not significant. The amount of money required is not significant. The technologies are mature. It's just a matter of government leadership to manage what right now is kind of a Wild West space. The United Kingdom has done that quite well. They've established their P&T office, which brings together focus for the whole government. There's Ministry of Defense folks in their P&T office, and they're looking across the whole nation's needs and have mapped out quite a good way forward for them to have a very good resilient P&T that can cooperate with Galileo and GPS, but doesn't need to.
I just love the contrast you made there, that they've achieved something satisfactory with only 4 antennas, because what I was understanding from NextNav's proposals is, I could be wrong here, but it was something like an antenna every 50 kilometers or even less.
Well, so NextNav has evolved. So they had what their metropolitan beacon system, which requires a lot of transmitters just in a metropolitan area. Their proposal to the FCC now is to leverage 5G telephone technology, right? And so 5G does not really cover all of the United States at the moment, although they say they provide a complete backup for GPS. And if the 5G telecom companies wanted to do this on their own, they could do it on their own. They wouldn't need NextNav. So again, yet another reason we're kind of skeptical about the NextNav proposal, and we're encouraging the FCC. And I have to say that we try to be technology agnostic at the R&T Foundation, but there were just a number of statements that the NextNav folks made to the federal government that we felt could not go unanswered because we didn't believe they were true, or certainly we thought they were at best misleading.
Okay, so that I think leads us to the last question, which is how much success the foundation has had in trying to bring about resilient P&T. So I think the sorts of commentary you've been making about market participants such as NextNav, but not to fixate on them, is an example of this. Have you got any other commentary in the last sort of 3 minutes?
So we did have legislation passed, the Resilient Navigation Timing Act of 2018 here in the United States, which required the Department of Transportation to establish at least a terrestrial timing system to back up GPS. Unfortunately, the successive administrations over in the executive branch have not chosen to act on that yet. We have, quite frankly, we have tried to exercise our influence through the press and other contacts. I think we've probably been most successful in helping the United Kingdom understand what they need and encouraging their approach, because it's not a technology issue. There's lots of technologies. This is a leadership issue. It's not a money issue either, because the money is de minimis, as the attorneys would say. I mean, the U.S. spends about $2 billion a year on just keeping GPS going. And, for less than 5% of that, we could have terrestrial and fiber-based system that synchronizes with GPS and provide and makes. Yeah, it could make the U.S. as good as China, nearly invulnerable in terms of our P&T. But yeah.
Are you saying that the U.S. presently is behind China in terms
absolutely.
of resilient P&T?
Yes, so GPS has not kept pace with Beidou in terms of being a global navigation satellite system. And that's been documented by the President's Advisory Board on space-based P&T. And in terms of overall resilience, so China has P&T in three orbits of satellites, and they have a terrestrial ELRAN system that covers their entire nation, as well as 1,000 miles offshore to the east. If you think about what's 1,000 miles offshore to the east.
The China Sea, yep.
And Taiwan. Yeah, and Taiwan.
Right, of course.
And And they have a fiber-based system with 295 timing stations, 20,000 kilometers, and it's all synchronized. So space, terrestrial broadcast, fiber, and the clocks all work
So
together.
they've done what you're recommending already, and
They
yet
have.
the US
They
has
have.
not.
Yeah, they have.
Wow. Wow. Okay. So not only is the US behind on high-speed rail, the Chinese have got 30,000 kilometers of that. They've also got the 3 levels of PNT to achieve resilience that you're, okay, interesting. I love this as a provocative way to end. Dana, you're doing a fantastic job. I really appreciate that you are so good and diligent in your job as the president of the Resilient Navigation and Timing Foundation, that you have come even on Geospatial FM. We'll do our best to promote your message. Thank you so much.
And we are a charity that depends upon membership fees for our existence. So go to our website.
There we go. Let's all sign up.
Join today, right? So there you go.
Very good. Love the message. Appreciate it, Dana. Have a great day.
You too. Thanks for the time.